In this video, we'll solve further problems from exercise 3.1. Question number 6. If y is equal to 2 sine alpha by 1 plus cos alpha plus sine alpha, then prove that 1 minus cos alpha plus sine alpha divided by 1 plus sine alpha is equal to y. So basically, you need to prove that this is equal to this. So we can say to prove 2 sine alpha by 1 plus cos alpha plus sine alpha, which is our term here, equals this term here, which is 1 minus cos alpha plus sine alpha divided by 1 plus sine alpha. So to do this, we will follow this as our trick or the methodology. Now, this is the given equation, or the given statement. So y is equal to this. So let's take this given equation and let's multiply it with 1 plus sine alpha minus cos alpha divided by 1 plus sine alpha minus cos alpha. So let's take our 2 sine alpha divided by 1 plus cos alpha plus sine alpha multiplied with 1 plus sine alpha minus cos alpha divided by 1 plus sine alpha minus cos alpha. Okay, now can you see the denominator is in the form of a plus b into a minus b. If our a is 1 plus sine alpha, you have the 1 plus sine alpha here, and if our b is cos alpha, then this is a minus b and this is a plus b. So a plus b, so we use this formula, which is a squared minus b squared is equal to a plus b into a minus b in the denominator. So let me say the denominator equal to 1 plus sine alpha squared minus cos squared alpha. Okay, so this is our a minus b and a plus b. So further you can expand this as 1 plus, it's like a plus b the whole squared. So 1 plus sine squared alpha plus 2 sine alpha minus cos squared alpha. Now we will take the 1 minus the cos squared alpha and replace it with sine squared alpha. So this is the third step here, which is 1 minus cos squared alpha is equal to sine squared alpha. So rewriting this becomes sine squared alpha. This is for the 1 minus cos squared alpha. Then you also have another sine squared alpha here. So another sine squared alpha plus 2 times sine alpha. Now if we take, or actually if we just add these two, this will become 2 sine squared alpha plus 2 sine alpha. So if we take 2 sine alpha out, so it's 2 sine alpha into 1 plus sine alpha. So this is sine squared alpha into 2. So taking 2 sine alpha out, you will end up with sine alpha, and here taking the 2 sine alpha, we have a 1. So this is our denominator. Now let's go to the given, what we have to prove. So from equation 1, okay, so this equation here, so we can say, substituting the denominator onto that, we can call this as our LHS. Okay, so LHS is equal to 2 sine alpha into, you have this here, which is 1 plus sine alpha minus cos alpha divided by your denominator will be now. So substituting 2 into this, you have 2 sine alpha into 1 plus sine alpha. Now 2 sine alpha and 2 sine alpha will be cancelled. So your LHS now will become 1. You can rearrange this, and 1 minus cos alpha plus sine alpha divided by 1 plus sine alpha. So this is our right hand side. So if you remember these steps, you will be able to solve this easily. Question number 7. If x is equal to sigma n is equal to 0 to infinity cos to the power 2n theta, and y is equal to sigma n is equal to 0 to infinity sine to the power 2n theta, and z is equal to sigma n is equal to 0 to infinity cos 2n theta into sine 2n theta, where your theta ranges between 0 to pi by 2, then show that x plus y is equal to xyz is equal to x plus y plus z. Now the hint that is given to us is 1 plus x squared plus x cubed and so on to infinity is equal to 1 by 1 minus x. So we have to use this in this given equations. So what we would do is, first let's start to expand this. So let's say our x is equal to, when you put n is equal to 0 into this, it is cos to the power 0 theta, so it will be 1. So when n is equal to 0, it is 1. Then plus, when n is equal to 1, this becomes cos to the power 2 theta. So cos squared theta. Plus, when n is equal to 2, it becomes cos to the power 4 theta, and so on. Now we know that by this given formula, 1 plus x squared plus x cubed and so on will be 1 by 1 minus x. So here our x is going to be cos squared theta. So this is 1 by 1 minus cos squared theta. So we will substitute the 1 minus cos squared theta with 1 by sine squared theta. Similarly, our y is equal to 1 plus, again using the same method here, it will be 1 plus sine squared theta plus sine to the power 4 theta, so on. So this is equal to 1 by 1 minus sine squared theta, and 1 minus sine squared theta is cos squared theta, so this will be 1 by cos squared theta. Then let's go to the last one here. So this would be z is equal to 1 plus, okay, when n is equal to 0, it will be cos to the power 0, cos to the power 0, so 1 times 1. Then when n is equal to 1, it will be 1 plus cos squared theta and sine squared theta. Similarly, when n is equal to 2, it will be cos to the power 4 theta, sine to the power 4 theta, and so on. So this can be written as 1 by 1 minus cos squared theta, sine squared theta. So cos squared theta, sine squared theta. So that's our z. Now we need to prove that xyz is equal to x plus y plus z. So let's take the left hand side now, which is x, y, z. So let's multiply x, y, z. So it's going to be 1 by sine squared theta into 1 by cos squared theta, which is our y, into 1 by 1 minus cos squared theta, sine squared theta. So further simplifying, we can say this is equal to 1 divided by sine squared theta cos squared theta into 1 minus cos squared theta sine squared theta. Now let's look at the right hand side. So our right hand side is x plus y plus z. So that would be equal to 1 by sine squared theta plus 1 by cos squared theta plus 1 by 1 minus cos squared theta sine squared theta. So if we're going to take the LCM and further simplify this, let's take these two first. So sine squared theta cos squared theta will be your denominator, and you will multiply 1 with cos squared theta and you will multiply this one with sine squared theta, plus you have 1 by 1 minus cos squared theta into sine squared theta. Now we know that cos squared theta plus sine squared theta is equal to 1. So further simplifying, this is going to be 1 by sine squared theta cos squared theta plus 1 by 1 minus cos squared theta into sine squared theta. Now further simplifying this, your denominator will now be sine squared theta cos squared theta into 1 minus cos squared theta sine squared theta. So you will multiply 1 with this term here and this one with this term here. So this will become 1 minus cos squared theta sine squared theta, and this is plus, multiplying this with this, you get sine squared theta cos squared theta. Now you can see that these two terms are equal, so minus plus and minus would get cancelled. So that is equal to 1 over sine squared theta cos squared theta into 1 minus cos squared theta into sine squared theta, which is equal to your LHS. Therefore, the proof that your x, y, z is equal to x plus y plus z. You can say hence. Question number 8. If tan squared theta is equal to 1 minus k squared, show that secant theta plus tan cube theta into cosecant theta is equal to 2 minus k squared the whole to the power 3 by 2. Also find the values of k for which the result holds. So you need to find the value of k and for which this result holds. So what you're given is tan squared theta is equal to 1 minus k squared. So let's take this 2 minus k squared and let's substitute our tan squared theta as 1 minus k squared. So that's our first step. So we know that tan squared theta is equal to 1 minus k squared. Therefore, 2 minus k squared to the power 3 by 2 can be written as 1 plus 1 minus k squared to the power 3 by 2. So 1 minus k squared is tan squared theta. So this will be 1 plus tan squared theta to the power 3 by 2. And we know that tan squared theta is equal to secant squared theta. So that's equal to secant squared theta to the power 3 by 2. So secant squared theta to the power 3 by 2 will become 2 and 2 cancel, will be 3. So that's equal to secant cube theta. Okay. This is equal to our RHS. Okay. Next, let me mark this. So next, what you do is you convert the LHS in the form of sine theta and cos theta. So our LHS here is equal to secant theta plus tan cube theta into cosecant theta. So substituting or rearranging them as sine theta cos theta. Now our secant theta is nothing but 1 by cos theta, and tan cube theta will become sine cube theta by cos cube theta into our cosecant theta is 1 by sine theta. So further sine theta here will get cancelled and this will become 2. So this is going to become now 1 by cos theta plus sine square theta divided by cos cube theta. So further simplifying this, you can take the denominator as cos cube theta. So our numerator will now become cos square theta plus sine square theta. So we have 1 by cos theta. So to make this cos cube theta, you have to multiply numerator by cos square theta. So this becomes cos square theta, and you have a sine square theta here. So this is equal to 1 by cos cube theta, and that's equal to 1 by cos theta is secant theta. So that's equal to secant cube theta. So which is equal to our RHS, which is here. Therefore, LHS is equal to RHS. Now we need to find the value of K. Now to find the value of K, since 1 minus K squared is equal to tan square theta, tan square theta will always be a positive value. So we can say that 1 minus K squared is greater than or equal to 0. So this implies, so 1 is greater than or equal to K squared, or our K squared is less than or equal to 1. So this would mean that our value K can be between -1 and 1. So that's the value of K.
Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.